Hello friends, now we are going to continue our next video. It is the LO3 of the CO1 course outcome 1. In that LO3 is calculate the area. That is the starting point of the word. Calculate is the starting point of the word in the course outcome. It is the larger part. We split it into small unit. We try to make it in the last portion, that is the calculate the areas. If you need to calculate, first we need to measure. In that, based on the instrument, we try to do the surveying. In that, first instrument is chain surveying. So based on the usage of chain, we need to measure and then we have to calculate the areas, right? So that is the specific outcome. For this outcome to be achieved, these are the following specific outcomes to be discussed. List the types of chains with their least count and their axis. What is chain and what are the types of chains available, and how we need to measure, what is the least unit in it, and what are the accessories we need to use, and what type of error will occur while doing the chain surveying, and how we can correct it. So describe the importance of various correction for chain surveying. With these things, how we can calculate the distance by applying the corrections. With applying the corrections, how we can calculate the areas also. This is the specific outcome we are going to discuss very slowly. Here we need to solve some problems, how the situation will be. For that situation, what type of correction I need to apply. For that correction, what will be the result, right? These are the little bit problem portion will also come. Before that, the theory portion we will try to complete in this video, right? So measurements of distance, that is the ultimate aim. Without measuring, we can't calculate anything. So the distance can be measured either by direct method, that is using tapes or chain, right? So just holding the chain and tape from one point to another, it will give the distance, that is direct. But I need to calculate the area, and with the respect to the proper direction and everything, I need to do some computation also. So for that, another method is the computative method based on the tachymetric or the triangulation. Already we have discussed this word, triangulation. This is new to you. We will discuss in the 4th unit. Triangulation, again we are dividing the larger area into small triangular units, such that I can easily able to calculate the area. How to calculate the area using triangle? We can measure the 3-side distance. With respect to that distance, we can calculate the area. So these are the methods can be used. So then, what is the principles of chain surveying? Is to divide the area into number of triangles. Already we have said the triangulation. So divide the area into number of triangles of suitable sides. The network of triangles is preferred here, as triangle is the simple plane geometrical figure, which is very simple and very easy to divide, which can be plotted with the lengths of its sides alone. In this case, there is no need for measuring the angle. Without measuring the angle, if we are able to measure 3 sides, we can able to calculate, right? I hope you have a thought process. What is the formula to calculate the area of triangle with 3 sides known, right? We will discuss in our doubt clearance session. You try to answer it, right? The specific outcome 1, list the types of chain with their least count and their accessories. To explain that, instruments used in chain instrument for measuring the horizontal distance, we need to either use chain or tape and arrow. This is the primary required to measure a distance, and to support that marking station on the ground, We need to use a ranging rod, cross staff, offset rod, pegs, plumb bob, field book. Field book means our surveying book has a standard where we can enter the measurement in a logical order. That is called the field book, right? So this picture try to show what is the chain. It has a brass handle at the both the end. It is like a holder, and you can see, I hope you can see, there is a small groove at both the end. In this groove the arrow can be holded in the ground, and we can hold at the maximum end, so that the end to end we won't miss any small gap, right? So we will get the entire chain as the full length. So from this end to this end is the total measurement. Here the picture is look like very small, but it has many cuts, right? So the total length of the chain here shown is 20 meter. There are many chains are available. Here what is shown is the metric chain, 20 meter metric chain. In that you first you I think you are seeing this, there is 3 rings, right? Again 3 rings. From the center ring to this center ring is called one link, L-I-N-K, link. Similarly, one link is the very least measurement that we can measure. Physically in our laboratory we are having the chain. You can see these things and you can measure what will be the distance. Now I say the value, you try to check in the lab, right? So the distance between this center ring to this center ring is 20 centimeter, right? So one link is 20 centimeter, means that is the least value you can measure with the help of the chain. So 20 centimeter means, if you convert to the meter, it is how much? 0.2 meter. So if it is a 20 meter chain, similar like this one link, how many link we require? Can you have a just 0.2 into 100 gives 20, right? So 0.2 meter one link into 100, it gives the 20 meter. So there must be 100 links in a particular chain for a 20 meter chain. If it is a 30 meter chain, then 0.2 into 150 gives 30 meter, right? So based on this number of links we need to measure the distance. How I can identify where is 1 meter, where is 5 meter? For that, at the every 1 meter there will be a small ring will be hanged, and at every 5 meter from this end, from that end it is 15, right? For 30 meter chain, or there will be a small shape like this. This different shapes are called tallies, right? So for every 5 meter there will be a tally. Next 10th meter there will be another tally. Next 15th meter another tally, and last is the 20 meter. So for the 30 meter chain, the number of tallies will be extra, right? So here it is a 20 meters and 10 meter less. Based on that, the tallies will be high. So this is the brass handle. These are the things steel, and this point to this point is a link, and for every 1 meter there will be a ring. If it is a 1 meter, how many links will be there? 20 centimeter is one link. Then 1 meter is how many centimeter? Is 100 centimeter. So 100 centimeter by 20, it is 5 links must be there. For every 5 links there will be a ring. So after that 5 meter there will be a tally. Then next 5 meter, that is 10 meter, there will be a tally. 15th meter, and the last is the brass for 20 meter. So this is the explanation for a chain. We hope we will see the instrument in our laboratory. So I have already explained the chain is composed of 100 or 150 pieces. Here the pieces means the links. That is the thing. The steel wire which it was made, the small portion, it is of 4 mm. The end of each link are bent into loop and connected together by means of 3 oval ring. Right. The ends of the chain are provided with handles for dragging. I have already shown it is made up of brass to drag the chain. Each wire with a swivel joint so that the chain can be turned without twisting. This is the swivel joint. It can be rotated at any direction. The length of the chain is measured from the outside of the one handle to the outside of the another handle. I already explained, from this outside to that outside. So tallies are fixed at every 5 meter, and brass rings are provided at every 1 meter length, except where the tallies are. In the 5th meter there won't be any ring, since there will be tally. So these are the main things you have to remember while using the chain. So now we come to the types of chain. The following are the various types of chain. First is the metric chain. Already I have explained about the 20 meter and the 30 meter chain. Predominantly we have tried to use this only in our laboratory portion, and major works are also they are nowadays used when for the SI unit, metric chain. But there are some other chains available: Gunter's chain or surveyor chain, engineer's chain, revenue chain, steel band or band chain, right? Still this revenue chain is in practice till now. All the Panchayat region, they still use the revenue chain for measuring the agriculture land or whatever the land in the unit only. But metric chain, it will give you all the thing in the meter, centimeter or millimeter, but the remaining things are give the measurement in feet or okay. So you should know to do how many feet is 1 meter, or what is the small unit of 1 feet, what is inch, everything you should remember, since it is required in the field directly. Many people try to speak in the local language how much feet it is. So at that time you should not say I am engineering student, I will speak in meter. You should not say. You should know the difference between the meter and the feet, and you should be able to convert it, right? So this is the one of the tasks you have to remember. So already we have discussed about metric chain is of 20 meter and 30 meter, tallies at every 5 meter, already we have seen. Gunter's chain or the surveyor chain, length is 66 feet, that is 22 yards. So here also there will be 100 links, so the each link is 0.66 feet. So which if you product the 100, it will give the 66 feet, used for measuring distance in miles or furlong. If you want to have the measurement in miles or furlongs, 220 yards, it's a mile or furlong, and you can get directly the area in acres. Engineer chain, it is of 100 feet. Compared to the Gunter's chain, it is still more longer. Here also there will be 100 links. Here each link is 1 feet. So here it is 0.66 feet. Used in all engineering survey. The revenue chain, it is a very small chain. It is 33 feet only. Number of link is 16. So what will be the one link length? You try to calculate. Commonly used for measuring fields in cadastral surveying. Okay. So this is the engineering chain, this is the metric chain, this is the Gunter's chain. Each has its own unit. Metric chain, the center to center is 1 link. We said the least count is 20 centimeter. Similarly, engineer's chain, it is 1 feet. It is 0.66 feet each one, right? So this is again the metric chain. Already we have seen the 20 meter. Now here it is a 30 meter, the end to end. A brass ring at every 1 meter. At the 5th meter there will be a tally. From here also it is 5th meter, means the same tally will be there. 10 meter, from here also 10 meter, from here it is 20 meter. So that would be the common center portion is 15 meter, it is of different. In some other chain it will be a round tally, some other chain it will be look like that. So this is the measurement units we try to use in the chain, right? You have to remember these things. So everything will have its own merits and demerits. It is often preferred for rough surface. Since it is made up of steel, we can use roughly, we can throw it, we can drag it, everything, and for any ordinary work also we can use it. Even in the forest or rugged terrain we can use. Still the chain is applicable in current also, it is not obsolete, it can be used. But the tape which will give the unit, in very small unit we can measure compared to the chain, but it cannot be handled roughly, and we cannot use in the rugged terrain or in any forest, since it may get teared off. So it is often preferred for the rough. It can be read easily due to its heavy weight. Since it is made up of steel, it has its own weight. The chain is often subjected to sagging. So there will be a catenary like portion will form when we holding the two ends at the air. So there will be a sag, which leads to accuracy of measurement. There will be a little bit variation. For these type of errors only we are going to make a correction. How we can make the correction, that we will see in the upcoming thing. And the accessories we have already seen. The arrow, this is the arrow, it has a proper straight steel with a hook like portion. The diameter of that hook will be 50 mm. It is nearly of 400 plus or minus 5 mm will be the total distance of an arrow, and it is of diameter is 4 mm diameter. In some thing there will be 5 mm also, no issue. And there will be a sharp edge portion, since it can be inserted in the ground to hold at what distance we need to measure, right? So the arrow are made of 400 mm in length, are pointed at one and other end is bent into a loop or circle. Okay. Next is the ranging rod. This is the ranging rod with shoe. This is called the shoe sharp edge, and with bands of white, orange, in some other thing white, orange, black, all the combination will be there. This is called the ranging rod. The length of the ranging rod is either 2 or 3 meter long with a heavy iron point 150 mm. This small portion alone will be 150 mm long at the lower end. Ranging rod are divided into equal. Each band is of 0.2 meter. I think this number is repeating from the chain also. The chain also has a least count of 20 centimeter. Here also we can use this band for measurement. If it is 20 means 20, 20, 40, 60, 80, right? So 80 centimeter means 0.8 meter. It is cutted and we can insert it. So it is more or less 2 to 3 meter height or length. That is a ranging rod. And cross staff, this is the instrument. It is of various type. Open cross staff, this is open end. It is of closed one French cross staff. Adjustable cross staff, here we can adjust the cross staff with grating also. Predominantly today we are using this only, open cross staff. With respect to this, we can setting out a right angle. If you are able to see through this straight line and this straight line, it is exactly 90 degree. So I can fix the corner of a plot or whatever it is in a proper rectangle, so that I can make the perpendicular thing. For that the cross staff is used. Next is the offset rod. It looked like similar to the ranging rod with the same band, everything, but at the top there will be a groove such that here we can hold on the hook of the chain or whatever to hold on. The offset rod is used for measuring the offset of short length. It is similar to a ranging rod and is usually of 3 meter length, right? Next is pegs. There will be wooden peg. At the top portion predominantly it may be a circular or a rectangular or square also. Mostly square or circle. Both the side it is 2.5 centimeter and the for a total depth of 15 centimeter. Right? It's a long wooden peg are used to mark the position of the station. Where the station has to be hold on, it should not be disturbed. For that we used to use the peg, but the arrow is to continue the intermediate thing. We try to use the arrows. Plumb bob, again to while chaining along a sloping road, the plumb bob is required to transfer the point exactly straight to the ground. For that purpose the plumb bob is used. So where and all the chain surveying is suitable when the ground is fairly level and open with simple details, where large scale plans are needed, not for the small scale. Huge area we can't go with the chain surveying. It is suitable when the area to be surveyed is comparatively small. That is this point is repeating here. It is suitable for ordinary works as it lends alerts due to continued uses. Sagging of chain due to its heavy weight reduces the accuracy of measurement. It can be readily read easily and repaired in the field itself. When the steel links are get bent, we can repair it with a hammer or thing in the field itself. It is suitable for rough usage. These are the suitability point for chain surveying. Unsuitability is for large areas crowded with many details. We can't use this chain. Unsuitable for wooded areas and undulating areas where we can measure the detailed things. These are the unsuitability for chain surveying. Some technical terms we have to remember while doing the chain surveying. That is the main station. It is a point in chain survey where the two sides of a traverse or triangle meet. A, B, C. A, B, C. This is the main station. From this only I can move the surveying, or I can even check whether the remaining points are set up properly or thing. So that is the main station. Continue to that subsidiary station. It is a station on the survey line joining the two main stations. See, here it is A, B, C. It is these are the survey lines where it can join the two main station also, right? So this station is called subsidiary station, and the line joining the two main station is the main line, main survey line. Tie line joining two subsidiary station is the tie line, and otherwise is the subsidiary line. Base line, it is the core line. It is the longest main survey line and passing through the center of the area. So it will be the mostly the longest line in any surveying area will be the baseline. Check line, to check whether how we have measured the thing very properly or not. This line is very much essential to check the accuracy of the field work. Say here A and D are the main checkpoints and check line. With respect to that we can check while doing surveying only. We can feel that how it is check line, what is main line. So here it is an explanation only, but you have to remember those terms. And the last one, the offset line. The perpendicular or the oblique distance of the object from the survey line is called the offset. It may be perpendicular or it may be oblique. Oblique means tilted, right? So we will continue the next topic in the next video.